let's start with this. So today we will be starting with differential equation. All right. So this is also a very important chapter. It requires a lot of practice, and I'm sure you guys will be able to doing it. All right. So now let's begin. So in this chapter, we will understand what different type of differential equations are. What is the order and degree of a differential equation? How do we solve a differential equation? And how do we form a differential equation? Sometimes if we are provided with a family of curves, then how do we form a differential equation? Then different methods of solving a differential equation like variable separable method, homogeneous method of solving a differential equation. All right. So differential equation is, it is the equation having derivatives. It is the equation having derivatives. So the exact definition is an equation involving independent variable which is generally x in our case, dependent variable, this is generally x. I'm not saying every time, but generally dependent is y. Then derivative of dependent variable with respect to independent variable. An equation involving independent variable, dependent variable, derivative of independent variable with respect to dependent variable, certain constants, is called differential equation. Is called differential equation. Like if you see this here, derivative of y with respect to x is given as 0. So this is a differential equation. Now if you see this, it is having cos x, which is say independent variable. It is having dy by dx, that is derivative of dependent variable with respect to independent variable. So this is a differential equation. Now if you see this one, not a differential equation. So in a differential equation, this derivative of dependent variable with respect to independent variable. In this equation, this derivative of dependent variable with respect to independent variable is mandatory. This is also a differential equation. There are two independent variables x and y, but a dependent variable du by u. So now we have two kind of differential equations. One is ordinary differential equation, one is partial differential equation. So this is the only differential equation of my concern and in our syllabus. Ordinary differential equation. Got it? Where we see the derivative with respect to only one independent variable. That is say dtu by dx square, second derivative of u with respect to x, du by dx, that is first derivative with respect to x, and a constant. And a constant. And a variable. But there are partial differential equations also which are not in our syllabus. But yes, they are also differential equations. So we won't be going into any depth for these partial differential equations. All right. Now order of a differential equation. Now what is the order of a differential equation? And then next point, maybe also understand the degree of a differential equation. So order of a differential equation is the highest order derivative you are getting in the differential equation. Got it? So this is what given to you is highest derivative present in the differential equation. So order of a differential equation is the highest order derivative you are getting in a differential equation. So dy by dx equals to 4x. So it is first order differential equation. Now, if you see this one, order 2, d2 y by dx square is there. See, dy by dx is also there, but what is the highest order is there? That is 2. So this is second order differential equation. If you see here, d3y by dx cube is there. So this is what? Third order differential equation. Got it? So order of a differential equation is the highest order derivative available there. Order of a differential equation is the highest order derivative available there. Got it? Now, if you see it here, order is what? 2. If you see it here, order is what? It's not 4. Order is what? Highest order derivative. So order is what? This 3. So order is 3. This is most very important to notice, like in this one. That it is order is its order is not 4, order is what? 3, because third order derivative is being done here. Got it? Now, what is the degree of a differential equation? What is the degree of a differential equation? So, degree of a differential equation is the power of the highest order derivative available in the differential equation. So degree of a differential equation is what? It is the power of the highest order derivative present in the differential equation. So like here, if you see, highest order derivative is 2 and its power is also 2. So degree is what? 2. Degree is not 4. Degree is 2. Here if I see, degree is what? Degree is 4 by 3 degrees given to me. Okay, see, there is a catch. There is a small catch here. What is the catch? Degree of a differential equation. Degree of a differential equation is defined if all the derivatives are written like the polynomial of derivatives. All the derivatives are written like the polynomials of derivative. So say like it is some fxy, then another function gxy into dy by dx, then another function hxy into d2y by dx square plus and so on. So if you see, all the functions are written as the entire equation is like in the form of polynomial of derivatives. Got it? Like here, if I see directly order, we cannot conclude. Order is 2 degree, we cannot conclude. So what do? I raise to the power 3 both sides. So it will become d2y by dx square power 4 is equals to dy by dx plus 4 whole raised to the power 3. Now the highest order derivative is 2. Its power is 4. So degree is 4. Am I clear? Now see, that point is also I have mentioned here. The exponent of all the differential coefficient. Differential coefficient means dy by dx square, d2y by dx square and so on. Should be free from radicals and fractions. The exponents of all the differential coefficients should be free from radicals and fractions. Got it? Next, degree is always a positive number. Positive as well as number. It cannot be 1 by 2, 1 by 3, 1 by 5. It is always a positive number. All right. The degree of a differential equation may or may not exist. Now, there is a possibility that the degree of a differential equation does not exist. Like if I ask you dy by dx raised to the power 1 by 2 is sine of x plus d2y by dx square. So currently, if you try, you cannot write this equation. Currently, if you try, you cannot write this equation in the form of derivatives, polynomial of derivatives. Because if you take sine inverse to the left hand side, it will be sine inverse of dy by dx. Got it? So this is not in the form of polynomial of derivatives. So degree not defined. Degree not defined. Am I clear? Now, just a small concept test. Find the order and degree of the differential equation. All right, you guys try it. Give your answer in the chat box. Quickly do. Everybody try. Yes, anybody? See the first one. Directly, order is okay. Order is what? 2. This is the highest order derivative available here. But degree you cannot say directly. So what we will do, we will raise to the power 4 both sides. So what do we get? d2y by dx square to the power 4 is y plus dy by dx whole to the power 6. So order is 2 and degree is 4. Alright. Now here if you see d3y by dx cube is the highest order derivative available. So order of differential equation will be 3. Now see, it is not written in the form of polynomials because it is e to the power d3y by dx cube. Now if you try to remove e, then d2y by dx square will come inside the logarithm. So that is also not acceptable. So what simply you will do, we will do that degree not defined. All right. Now family of curves to differential equation. How do we do it? From family of curves, you get differential equation if you differentiate it. And from differential equation, this is a wrong side arrow. From differential equation, you will get family of curves if you integrate it. Am I clear? So from family of curves, you will differentiate to get the differential equation. And from the differential equation, we integrate it to get the family of curves. Now, how do we form a differential equation? All right. So to form a differential equation, we first of all differentiate the independent variable. Sorry, we first of all differentiate with respect to the independent variable say x. As many number of times there are independent arbitrary constants. Now there are two important words, that is independent arbitrary constant. Am I clear? So what is independent arbitrary constant means? Like if you see somewhere x plus y equals to k. And then you see somewhere x plus y equals to k1 plus k2. Now see, there is one constant, arbitrary constants k. You put the different values of k, you keep on getting the different members of this family. Now there is k1 plus k2. So using this k1 plus k2, does it mean there are two constants? No. You replace k1 plus k2 by some another k, and then you get x plus y equals to k. That is again one equation having one independent arbitrary constants. So what do? We can merge as many constants as we can to get the independent arbitrary constants. Like in some question, you are getting k1 times e to the power k2. Am I clear? Now this k1 is constant. This e to the power k2 is also constant. So keeping all of them all together, you can replace by some another k. So there are not two constants. There is only one independent arbitrary constant. Got that point? There are not two constants. There is one independent arbitrary constant, that is k. So in a differential equation, we first of all differentiate the given family of curves with respect to independent variable, certainly, which is x, as many number of times as many independent arbitrary constants are there. Independent arbitrary constants are there. And the only priority is to eliminate those arbitrary constants. Eliminate the arbitrary constants. Now, after elimination, whatever do you get is what? The differential equation. Got it? Now see, one simple example I will take. Say you have an equation y equals to mx, where m is an independent arbitrary constant. Now somebody asks you what is the differential equation. Got it? So I can differentiate it once. Dy by dx I got as m. Then you replace m, you get y equals to dy by dx into x. Now this is the differential equation. Now say some student is telling me, sir, don't just put the value of m, differentiate it again. So you get d2y by dx square equals to 0. Why is it not the differential equation? Yes, it is not the differential equation. Bishan, Priyadarshini, nobody is responding. Anyways, so this is not a differential equation. First of all, as there was only one independent arbitrary constant m, so we were supposed to differentiate it once only. Got it? Secondly, now say if this is the differential equation for this curve, that means its integration should give me this curve also. So if you integrate it once, you will get dy by dx as some constant. Got it? And now you differentiate it once again, then you get y equals to kx plus say some c. Now there came two independent arbitrary constants. Yes or no? So if it could have been the curve, this is my answer. But if this is the curve, then this is your answer. Got it? You are not going to differentiate any equation more than the number of times independent arbitrary constants are there. Got it? Now you have seen this equation. Somebody asking you find the order of the differential equation. So to get the differential equation, you just see how many independent arbitrary constants are there. Got it? So to find the order of this differential equation, you just see how many independent arbitrary constants are there. So it is y equals to c1 plus c2. The sign of x c3 can be written as sin x cos of c3 plus cos x sin of c3 plus c4 e to the power x into e to the power c5. I can write it like this. Now see this c1 plus c2 multiplied. So c1 plus c2 cos c3 sin x, c1 plus c2 sin c3 cos x, c4 e to the power c5 into e to the power x. Got it? Now see, I can combine all these three constants all together. I can combine all these three constants all together, and I can combine these three also. So what do you get? You get k1 times sin x plus k2 times cos x plus k3 times e to the power x. Got it? Now to get the differential equation, you are going to differentiate it 3 times because there are 3 independent arbitrary constants k1, k2 and k3. So if you differentiate it 3 times, you are going to get what? You are going to get, tell me, d3y by dx cube as the highest order derivative here. So if d3y by dx cube is there, that means order of differential equation is 3. Got it? Now let's see a simple question. Find a differential equation whose solution represents the family. That is c times y plus c whole square is x cube. C times y plus c whole square is x cube. So it is c times 2 into y plus c dy by dx is 3x square. First time differentiation. Now, before doing it any further, you just have to see how many independent arbitrary constants are there. But I see only one, that is C. Yes or no? So you just try to find the value of C from both of them. So what do I do? You do one thing, you square the second equation. So it is 4c square into y plus c whole square dy by dx whole square is 3 3 is 9x to the power 4. Got it? Now, if I divide this equation 1 and this equation 2, I'm going to get the value of c square. Right? So, if you divide both of them, you get 4c into dy by dx whole square is 9x. Now, this value of c, you replace there is 9x upon dy by dx whole square into 4. You just replace this value of c here. Got it? So it will be 9x upon 4 into dy by dx whole square into y plus 9x upon 4 into dy by dx whole square is x. So this is the differential equation you have been looking for. Am I clear? Have a look once quickly. Now, there is a solution of it. See, you have a differential equation. Now you are going to solve it. Now in the solution, while you will be integrating it, so after integration, you are going to insert a constant of integration c. So for that different values of c, you are going to get different solutions of that equation. So the solution which is there in terms of c is what we call the general solution of the differential equation. Am I clear? So solution which is there in terms of C is what we call the general solution of the differential equation. And then there is a particular solution. Particular solution is what? They are saying that we are looking for the curve of that family. We are looking for the curve of that family which is passing through 1, 1. Got it? So we are looking for a curve of that family which is passing through 1, 1. Am I clear? So that means you just put the 1, 1 in that curve, you get the value of C, put the value of C, then you get a unique solution. That is what we call a particular solution. So general solution is what? You just solve the differential equation, integrate it, put an extra constant into it. That is the general solution. And for the particular solution, they provide you extra condition that that the curve is passing through that particular point, and we get the solution. Now, differential equation of first order and first degree. This is what is there in our syllabus. Got it? So a differential equation of first order and first degree is of type dy by dx plus some function of xy is equals to 0, which can also be written as m times dx plus n times dy equals to 0, where m and n are functions of x and y. Got it? Now, solution of a differential equation. Now, the question that comes is how to solve a differential equation. You must have done in your 12th syllabus if it is completed. So, the solution of a differential equation of first order and first degree, first of all, are in our syllabus. We solve a differential equation using a variable separable method, homogeneous equation method, and then linear differential equation method. Correct? So, variable separable method is the easiest one. Moreover, most of the questions ultimately reduce to variable separable method. Now, this homogeneous method and linear differential equation methods are something which are quite different. So that we will do. So the first thing that comes is solve the differential equation 1 plus x y dx is equals to y minus 1 x dy. Got it? So it is variable separable method. First of all, we are doing simply nothing much to do. Accumulate everything related to x to one side and accumulate everything related to y, even dy, to one side. Got it? Like variable separable method में you have dy by dx as some function of fx upon some function of fy. So put everything related to y to its side. So it is fy dy is equals to fx dx and then integrate it. Am I clear? So now it is what? Here dx is there, so keep everything related to x to left side. Y minus 1 upon y dy. Am I clear? So it is 1 by x plus 1 dx is 1 by y, just a moment, is y minus 1 by y, 1 minus 1 by y dy. Now integrate it to the both sides. All right. Now integration of 1 by x is ln x plus x is equals to integration of 1 is y, 1 by y is ln y plus some constant. So this is the solution of the differential equation. That's it. And this is what we call the general solution of this differential equation. Am I clear? To get the particular solution out of it, they will provide you some extra condition like this curve is passing through 1, 2. So you just place that value, get the value of C, and then get the equation of that curve. Am I clear? Now see there another question. Solve the differential equation. So take a moment, try to solve it on your own once. Quickly. Go through it quickly. Now see, it is x cube into 1 minus y square dy by dx is equals to, take minus common, it is y cube into 1 plus x square. Am I clear? So the question becomes x cube upon 1 plus x square, not this way, dx is there. So it will be 1 minus y square upon y cube dy is minus of 1 plus x square upon x cube dx. Got it? So it is 1 by y cube minus 1 by y dy is minus of 1 by x cube plus 1 by x dx. Now you integrate both sides. So right after integration, we'll add a constant. So 1 by y cube is what integration? Y to the power minus 2 upon minus 2 minus 1 by y is ln y is equals to with a negative sign. 1 by x cube is what? X to the power minus 2 upon minus 2 plus ln x plus constant. See once. So it will be 1 upon 2 1 by x square plus 1 by y square plus ln of y upon x plus constant is equals to 0. This is going to be your answer. Am I clear? So this is your answer. Now, equation reducible to variable separable. Now, what is this reducible to variable separable? Is something like you make some change in the equation, like you put a substitution. Mostly what we do, we put a substitution. So we put a substitution to it, and then we convert this equation to the directly variable separable. Got it? Generally, the kind of question that we see here are dy by dx is given as a function of ax plus by plus c. So what do? We put ax plus by plus c as t. Now you differentiate it with respect to x. So a plus b dy by dx is dt by dx. So dy by dx became what? Dt by dx minus a into 1 by b. So dy by dx is 1 by b dt by dx minus a upon b is equals to ft. Alright, multiply the entire equation by b. So dt by dx is equals to b f of t plus. So dt upon b f of t plus a is equals to dx. Now you integrate both sides, you will get your answer. Am I clear? Done? Now see this question. Same kind of question it is. Let x plus y is equals to t. So 1 plus dy by dx is equals to dt by dx. 1 plus dy by dx is equals to dt by dx. Now put dy by dx is what? Dt by dx minus 1 is cos t minus sin t. So dt by dx became what? Cos t minus sin t plus 1. So dt upon cos t minus sin t plus 1 is equals to dx. Now you integrate both sides. Now the another challenge is how to integrate the left side. Got it? So that we will be doing it by dt upon constant will be there. 1 plus cos t is 2 cos square t by 2 minus 2 sin t by 2 cos t by 2. Or the better way we can do, just convert the entire equation into half angle of tangent. That would be much great. So it is 1 minus 10 square t by 2 upon 1 plus 10 square t by 2 minus 2 tan t by 2 upon 1 plus tan square t by 2 plus 1 minus tan square t by 2 upon 1 plus tan square t by 2. Correct? So now it became 1 plus tan square t by 2 will go upside. It will be 1 plus because 1 was there. So after taking LCM. So it will be secant square t by 2 dt upon 2 minus 2t. And because this one what t square 10 square t by 2 and 10 square t by 2 will cancel. It will be 2 minus 2 tan t by 2. Got it? Means it is tan t by 2. Now simply derivative of denominator is what? Derivative of denominator is what? Minus of secant square t by 2. Create a minus sign extra here and plus constant definitely here. So x you got as ln of with a negative sign ln of denominator. So it is 2 minus 2 tan t by 2 plus c. And then replace this t as x plus y. So it will be x equals to minus of ln 2 minus 2 tan x plus y by 2 plus constant. Got it? See, once the question is easy, little bit of different integration part is tough. Got it? Now, let y equals to yx be the differential equation e to the power x under root 1 minus y square dx plus y by x dy equal to 0, where y1 is minus 1, find the value of y3 whole square is. Okay, you guys try it on your own. Then we will run a poll and see how many of you could have been able to do it. Quickly. Yes, how to do. Now, mark your answer in the poll if you have solved it. Quickly. Two people responded, answer is Bombay. Now see, only two have been able to do. See, e to the power x under root 1 minus y square dx plus y dy upon x. And let's take it to the right side. This is equal to with the negative sign. So it will be x e to the power x dx is minus of y dy upon under root of 1 minus y square. Am I clear? Now, if you integrated both the sides, you will add a constant. This x e to the power x, it can be integrated using by parts. So first into integration of second minus integration first ka derivative integration of second is equals to minus of integration y dy upon under root of 1 minus y square. That's constant. Okay, let's do one thing. Multiply it by minus 2 so that derivative of denominator gets converted into numerator. So it is f dash x upon root fx. So answer will be 2 root fx. So it is x e to the power x minus e to the power x is equals to 2 under root of 1 minus y square plus constant. Now, while x equals to 1, y equals to minus 1. Put it here. So x equals to 1 means e minus e is 2 into under root of 1 minus 1 plus c. So in that case, c goes 0. Got it? So if c is 0, so you get x e to the power x minus e to the power x is 2 under root of 1 minus y square. C is 0. Am I correct? Now they're asking for y3. So put the value of x as 3 to get y. So it is e cube into 3 minus 1 is 2 under root of 1 minus y square. Got it? So under root of 1 minus y square is e cube. Square both sides. 1 minus y square is e to the power 6. So y square is what? 1 minus e to the power 6. Oh, 4 is also there. Where did it come from? This f dash x upon f. Okay, I multiplied by 2. I have to divide by 2 also. So then this 2 won't come. This won't come. So this won't come. This won't come. So it will be 2e cube. So 4e to the power 6. So 1 minus 4e to the power 6. This will be your answer. Got it? Well, anyways, thank you so much. I hope I have been able to justify with this session. So in our next class, we will further proceed with the homogeneous differential equation. In the meantime, I will require your feedback over it. So just fill it off.